Hi everyone, Mr. Chaffee here. Today we're going to be working through Chapter 3, the normal distribution. We're going to start off talking about percentiles. So let's define a percentile as the 100 equal groups which a population can be divided into according to the distribution values of a particular variable. So these percentiles will always be whole numbers ranging from 1 to 99, and they're just a way to break a population into 100 equal groups to be able to easily understand where a specific value falls within that distribution. My handwriting is slightly better than on the iPad, but not by much. As you can see, that's just how I write. But I'll try and keep it as neat as possible for you all. So let's take a look at an example for a percentile. When you receive your PSAT scores, you're told that your percentile rank. Suppose your score report said that you were the 85th percentile. Let's interpret this. So if we have our percentiles from 1 to 100, or 1 to 99, we've got the 85th percentile, which says we scored better than 85% of students that took the PSATs. We're in the 85th percentile. We're in that top 85% category. So let's just say you scored better than 85% of people that took the PSATs. Now let's recall our 5-number summary, our min, Q1, median, Q3, and our max. Let's draw a box and whisker plot to represent those. So the nice thing about those box and whisker plots, there actually already are an introduction to our percentiles. So these are just some really simple, easy to understand percentiles. So basic box and whisker plot, we want to draw our center box with our whiskers on the side and our median in the middle. And let's go ahead and label everything. We've got our minimum value on the left-hand side here, 2.7. Our Q1 is 4.5. Our median is 5.6. Q3 is 7. And then our max is 10.1. So if we're saying, what's the 25th percentile? Well, that's going to be the number at which 25% of our observations fall below that, which is the same thing as our Q1. Our Q1 is the value that segments our first 25% of our data. Everything below our Q1 represents 25%. So our 25th percentile here is going to be 4.5. Our 75th percentile is asking us for the number at which 75% of our data falls beneath it. So we've got, if our Q1 is 25% here, let's do this in a different color. Our Q1 is 25%. From Q1 to our median is another 25%. From our median to our Q3, that's going to be 25%. And then from our Q3 to our max is our last 25%. So if we're looking for our 75th percentile, we can see 25 plus 25 plus 25 gives us 75%, falls below our Q3, or our number 7 here. So in this case, 7 is our 75th percentile. Similarly, our 50th percentile, that's just going to be our median. Our median always falls exactly in the middle. So we've got that 50% here that falls beneath that median, giving us 5.6 as our 50th percentile. So now we've got an example of heights from a third period class in inches. And notice that they all are already arranged from least to greatest, so that's a little easier for us to work with here. And now we're being asked to find the percentile of the person whose height is 65 inches. Well, the first thing we're going to need to do here is figure out how many values that we have in total. So as you can see from our group here, let's just count through. We've got a total of 15 values. So let's say 15 total heights. And then if we're looking for our 65, that's right here. So we want to see who falls below our 65 inches. It's 1, 2, 3, 4, 5, 6, 7, 8. We've got 8 values, or 8 heights below 65. Now, using these two numbers, we can figure out our percentile from here. So let's figure out what percent of these data values fall below that 65. We can say 8 over 15 times 100 is equal to 53.3 repeating percent. But our percentiles always fall in a whole number, so we want to have everything that's included below that 65. We need to round up to the next whole number to include this decimal in here. So we're going to go and say this gives us the 54th percentile. So everything that falls below that 65 represents 54% of our data. Now for moving on, interpret what this means in context. Well, this person is taller than 54% of the class. Now, a new student was added to the start of the second semester. She is 67 inches tall. What percentile is she in? So now this is going to change our data set a little bit. We're going to plug in 67 right to here. Now our total number of data entry values changes, so we can say our new total is no longer 15, but let's just say 16, because we're adding that extra person to the class. And now let's count all of the people that fall below that 67. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 fall below 67. So let's say 11 below. Now it's the same idea here. We want to find the percentage that that group of people that fall below 67 make up. So we've got 11 over 16 times 100 is equal to 68.75%. And we want to round up to include everything in our percentiles again because they are whole numbers. So here we're going to say that is the 69th percentile. All right, let's try one last example on this first page together. Below are the grades for my third period class, and we have a list of all of these grades. Let's find the percentile for the person whose grade is a 63. So now our values are not in order, so we're going to need to arrange them. And just as a quick reminder, an easy way to do that, we can use our calculators here. So if we go into our stats menu, our edit, we want to add all of these heights within our list there, which I had already done beforehand. So I have all the heights in our L1 here. And what we want to do to make them in order, we're going to hit stats. Sort A gives us sort to ascend the list, put it in ascending order. So I'll hit enter on that, hit second. Then the L1 key down here, the 1 button. So that L1 populates there. Sort. Sorting's done. Now when you go back into your list, you can hit edit again. They should all be in order. which I won't make you recopy down the order. As long as you have that there that's easy to read, that's good enough for me. So when we say what percentile is the person whose grade is a 63, well, I'm going through my list and I'm looking for 63, and that is the fourth number on our list, which means we've got 3 numbers that fall below that. In our total of our list, we had 19 entries total. So we could say we have 3 below and 19 total. So now it's just the same process. If we're trying to find what percentile we need, we're going to turn this into a percent. Let's say 3 over 19 times 100 is equal to 15.79%. So to get our percentile, we're going to round up, say we have the 16th percentile here. Now, a student in the 3rd period took her test late and scored a 73%. What percent are they in? So now we have to add a new score to our list. So you can go back in your calculator if you'd like, and then add that one more score in and then resort. And then once you do so, we can see 73 is going to be our 9th number in our list. So we've got 8 numbers below. So 8 below, and now our total changes to 20 because we added that extra person. So if we were trying to find a percent here, we're going to take 8 over 20, multiply it by 100, and that's going to be 40%. This one we don't need to round at all, it's nice and even. So we get she is in the 40th percentile.